OpenFlow. Hi. So I'm Steve Noble. This is Martin Winter. We're both with the Network Device Education Foundation, which is a nonprofit that we founded back in 2013. Today, what we're going to talk about is a very simple deployment of OpenDaylight and OpenFlow into just a simple network. So I'll give you a little bit of background. So NetDef, founded in 2013, it's a 501c3 charity. So we do receive money from donations, and that's how we run everything. We do things like this, training. We also manage the open source routing project, which Martin is the best representative of, which would be Quagga. And then we do router and SDN testing. And so with the router and SDN testing, we have these different sites. So we have router analysis and SDN testing, and then open source routing. Me, I'm just happen to be the president of the board. I'm just here to present and talk about this. I recently was put on the ONF Software Leadership Council, for what it's worth. I was previously with Sideband Network, Cisco, Procket, and earlier with Exodus, which is where I met this guy. I do lots of things, movie roles. But anyway, so to get down to it, what we've got is a very simple setup of 4 devices. And 2 of those devices are, well, PK8 switches. So we're numbering from the top. We've got on the top, we've got the controller, the PC. Second, we have device number 1. Next, we have a TP-Link box that's running as device number 2. We've got a Cisco 1800 running as device number 3. And then we have another PK8 Pronto box running as device number 4. Both device 1 and 4 are OpenFlow capable. And in this tutorial, what we're going to essentially do is convert them over and connect them up to OpenDaylight and see that everything is working. On top here, although they're really hard to see, and we apologize for that because we normally use these for smaller demonstrations, we've got 4 boxes that are sending traffic back and forth between them that are confirming that everything is working within the network. Do you want to talk about them?
Yes, so I can. So first of all, also keep in mind this is a routed network. So all these nodes here showed before, they're running routing protocol, OSPF and BGP. What we have here, these boxes basically simulate a host each. So just think about your average server. And go back. And what you see here, if you're in the very front or have extremely good eyes or some binoculars, you see basically the different hosts. So each host, so the picture is the host 2, and he basically pings and sends traffic to all the other hosts. You see a time there, which is the ping time, how long it reaches, and you also see yellow and green bars which turn from the right to the left. And you basically, if you see green and yellow, it's basically can send and receive. The bottom one, you see ping doesn't work. It's basically maxed out, basically at 1 second. And you see the yellow still is basically, it still receives traffic from the other one. So we see there is a one-way traffic, but it cannot send it, so it doesn't get anything back. So it's just a way to show like it's still one-way traffic still goes through, but not both directions. You see a short outage there too. Basically each bar is about 1 second at the bottom there. So that's basically what it shows here. And you will see it's there running live, so if you can see up here the colors a little bit changing, the bars disappearing, that basically you know you have a short outage or longer than, depending how long it happens.
So I've been putting stuff up on YouTube and Twitter and publishing it, and we've been trying to get it out there so people had an idea of what we were doing, since obviously with hardware it's hard to demonstrate it with a lot of people in the room. But what we have is a network where we're running OSPF between all 4 of the devices. And then we're running BGP, and we're announcing these 10 networks. So each of these hosts is announced via BGP. The BGP is done via the loopback address on each device, and then each device is peering it's a full mesh. So it's a pretty simplistic setup, but the goal here is not really to be complex, it's to just go through a simple conversion. So this is the interface configuration for the devices. This probably doesn't mean a lot to everybody. It looks very similar to a Juniper type configuration. And then I didn't expect that to happen. Sorry about that. And then for protocols, you can see we have the BGP, and we have a peer. I've commented out a lot of them. I've got an export command. Some of you who might monitor IETF have noticed that there's been a lot of discussion about BGP and the fact that when you bring up peers, you should have filter lists and things of that nature. So we do that by default, just to make sure that everything is clean. And then for OSPF, you can see we've got the loopback, and we're using just area 0, and we've got the interfaces in it. I'm going to step through this one here. Okay. So here's a Cisco-like configuration. And here you can just see, again, same thing. We've just configured the sub-interfaces, and then we've set up BGP peering between all of the devices. So if that all makes sense, then I'm going to talk a little bit about what we're going to do first. So here is a picture of what the setup will look like in a minute. What we're going to go ahead and do is we're going to go on to the L3 device number 1, and we're going to change the configuration, and we're going to take it from being routed interfaces and change it over to being OBS controlled, OpenFlow enabled interfaces, and connect it up to the controller here. So the main things that you'll notice is that we're migrating the interfaces from the L3 device 1 over onto this box, the box at the top that's running Quagga, and it's running OpenDaylight. Mind you, it doesn't have to run Quagga. It can run anything. It could be running a CSR. It could be running anything. The point is we're just using a simplistic setup as possible here. So really have to apologize. So if you were here for the earlier talks, I think that you got a good idea of how OpenDaylight works and how you install features and all of that. And so I'm not going to cover that. Basically, I'm going to point out I downloaded Lithium directly. I installed OpenJDK. I started using bin carafe, and then I install just 3 features. Basically, Deluxe, so I have a UI, the OpenDaylight L2 switch, and technically, the L2 switch will pull in the OpenFlow plugin automatically. But that's kind of how it is. Oh, geez. So for the OBS configuration, it's pretty simplistic. We've got a bridge. We've named it switch 1. We have the controller configured, all of that. I've got the first one set in a fail mode secure so that it won't pass traffic unless it's connected. And then I've just got the interfaces added. So let me go ahead and step out here. And let's see. Probably need to make that bigger. Okay. So hopefully that's 21. You want it bigger? Oh. So here I'm just going to go ahead and start up OpenDaylight. Let's see, distribution. And it's going to give you this error. We actually talked about this yesterday, that a lot of people complain about the Java home not set error. But if you've only got one Java on the system, it's not a big deal. So, whenever you see that, it just means, that you haven't exported it correctly, but you should be okay. So now that we have that up, we can do the choose list minus I. And then we can grep out OpenFlow plugin. Basically, we can see that we've got the OpenFlow plugin, the standard one. This is not the new one because the L2 switch basically depends on the old one, not the new one. How do I kind of... Okay. So this is going to be fun. Windows. Okay. So this is L2 device 1, and here you can see I've just got it configured. I've got a trunk port, I've got native VLANs, I've got the device connected, there's the BGP, there's all of that. So what I want to do is I'm going to go ahead and remove quite a few things and change this over. So I'll explain these, the first couple as I do them. Basically, set XOVS, for those of you who haven't worked with PCOS, the operating system from Pika 8, it essentially says, allow me to have both OpenFlow and non-OpenFlow interfaces. Then I'm going to delete the interface family. And you're going to see here that it's deleting the family. It's removing the VLAN. I'm going to enable cross-flow mode. And all cross-flow mode is essentially saying, give this control over to OVS. And so for Pika 8, they're just running a pretty straightforward OVS system on their switch. They've modified it a bit to work with their forwarding hardware, but it's OVS. So on the first one now, we can do a show, and what we'll see is that we have cross-flow enabled in the family, and my family did not take, so give me a second. Family. Oh.
If anyone has a USB key from the wildcard section in Grand Ballroom E, they're like out of them. So I will walk around and please hand me that USB key, and I will bring them back.
Oh, anyway. So I'm going to go ahead and just paste these others in, and you can see that they're taking. I'm removing the first couple of ports, and then I'm going to add the fourth port in. I'm going to go ahead and delete the VLANs from the box. I'm going to delete the interfaces, and then I'm going to delete the policy. And so show will now show that we've deleted the family. So you can see here we've got a minus. We've added cross-flow. And as we go down, that. And then I'm going to go ahead. Go ahead. On L3 device number 1. I'm going to have someone echo. My hearing is really bad. Oh, okay. So the topology is as follows, and we're working on L3 device number 1 right now. So at this point, I should be able to remove the routing protocols. I'm going to just minimize that out. And I see the problem. So at this point, I've essentially removed all of the protocols. I've removed everything. And then what I'm going to do is I'm going to commit. And if, oh, my mistake. I still need to remove something. Oh, okay, so VLAN 102 didn't get deleted. That doesn't make sense. Always with the live demos. That one's there, that one's gone, that one's gone. Why is that one interface? Oh, I see. And VLAN interface. VLAN 102. Oh, for gosh sakes. Okay. We haven't plugged in the controller, I've just been informed. So I've got a connection that goes from this switch over here, and what we should hopefully see here in a second, if I've done everything correctly.
You see in the top how the traffic dropped a lot of the part. This one doesn't receive anything right now.
This one is only
So
receiving?
this is like the node 1, so connected to that route which we changed over.
So you're going to see that everything's going to start to recover. And if I go over to the box again.
And remember, it requires BGP and OSPF in our network configuration for it to work, so it takes a bit longer. Now it just recovered completely. That was the last one, node 1 to node 4, which just kicked in.
Can you do the show commands? So here I'm just logging into Quagga, and we're going to show that now the Quagga instance that's running on this controller at the top here is doing the BGP and also doing the OSPF. Okay. So are there any questions here? Is everything making logical sense? Go ahead. Go ahead.
Can you go back to the topology chart? See, what is the data bus? I mean, for the data traffic and also control traffic. I mean, I think you did a good demo, but how that's related with the topology?
With the topology?
Yeah, I mean, what does data bus looks like? What does control data bus looks like?
Oh, so I didn't really explain that well enough, did I? So let me bring up this picture, and it actually has it all outlined on it. So what we have is a management switch here. I can't use my mouse on it. So we've got a management switch here at the bottom, and the Quagga OpenDaylight box has 192.168.21.17 attached to it. And then L3 device 1 has 192.168.21.111. And the management is being done over the out-of-band network. And then the physical interface, Gigi 1.3, is the one that I had to connect up here in order to have the traffic work. I don't want to step too far forward or the mic might feedback. So this is the physical link, and then all of that is that way.
So look at from this way. Before we had basically each node basically a separate router instance or like a normal, like the first thing. Leave it on.
My mouse
Okay.
is gone. Okay.
So initially we had all this like the normal, all the yellow part is in OSPF, and the green part is basically in BGP. So we had a normal, full like OSPF like core for like as a routing protocol, as an internal routing protocol, and we had all the hosts over BGP connected in it. And each device basically can look at it as a router. And when we changed over, basically we changed it over from that router device to split it up using ODL to basically take the layer 3 out on top of the ODL controller.
Sorry. I can't see my...
Oh.
I can't see my mouse. I apologize.
So we basically pulled it apart. It's like in a distributed device. So the L3 device 1, which you see now, which we convert, is now doing the forwarding. And the control plane is now on the OpenDaylight controller with Quagga. Quagga, for the ones who are not that familiar, that's basically the BGP, OSPF, all the routing protocols. So the routing protocols are now on the OpenDaylight controller, controlling the switch itself with OpenFlow and doing the forwarding down there.
So let me get out of that.
Does that make it clear, or any questions specifically from the topology?
We're going to do one more in a second, so, but go ahead.
Yeah, so I saw that you had two connections, like one connection to the switch and then one for OpenFlow. Was wondering why you need two different connections.
So you're talking about this OpenFlow connection there.
Yeah.
So you can do OpenFlow commands over an internal connection, but it requires that you, right now at least in these systems, you have to kind of hard code everything. And I don't want to do that. I want this to basically detect by itself. So this is the controller itself here. You can see that we have the host 10.1.1.10, and we have the link to device 4, we have the Quagga interface, and we have the link to over to device 2. That all making sense at this point? Go ahead.
I'll repeat the question. So if I have two AS, one with OSPF and the other side is ISIS, between the ASs, do I need to have any specific config on the inter-AS link?
So basically, you only have ASs for BGP. ISIS, you can have different areas there. But AS, which is autonomous system, that's basically a BGP-specific part. So you could do an external BGP connection with the, which you could do different from the topology. But that shouldn't really change much on the setup here. We haven't really changed anything on the BGP or OSPF configuration. We just basically separated the control plane out to the OpenDaylight controller.
And part of the goal here is, and this is something I've been talking to different vendors about, is that you can kind of imagine that if this is a route processor and this is a line card, this could be a second line card in the same system under the same control. And so part of the reason we're doing this demo is to show that. But here you can see we've got the flows from all of the different destinations. They've been programmed into device 1. Let me go ahead and down. You see this is all still good. And then I'm going to show you how this is set up right now. So the next step in this process is to convert the second box over. And the link to the second box is actually connected to this interface P6, P1. And when we do that, we have to configure the IP addresses, we have to put the networks into BGP, and we need to basically take over for this. What? Can't hear you. Okay. So I'm going to log into the second. Okay. Okay. So migrating the second device. Again, this is essentially the same thing done. So what we're going to do is we're going to take L3dev4, we're going to convert it into OBS mode, and we're going to connect it up to the same OpenDaylight controller on a different interface to Quagga.
So we are basically merging the two layer 3 devices, 1 and 4 together, and have the same OpenFlow control, OpenDaylight basically controlling both of them. So the configuration changed a little bit because we're basically merging the whole configuration.
So in this case, it's easier for me to just go in and copy the Pika OBS conf over Pika startup, and then I'm going to restart it. And while I'm doing that, I'm going to need to, A, connect up the link. You want to do that? And B, I'm going to need to configure the interfaces. So
we skipped the configuration bit on the PK8. It's very similar to the one before, so it's not really that much difference. If you can see up here too, you notice that the traffic now basically stopped between some of the nodes too. So like host 4, basically to host 2, host 1 to host 4 as an example is like gone, which is the one which we're merging. Some of the other functions still running there.
okay, so once this has restarted, we're going to see hopefully some of the, I'm not sure what the status is of these. Host 4 may actually start receiving, no? Okay. So the last thing I need to do that in, if I've done everything, let's see. Three to one. Why am I not getting? Oh, I see. So there's 3, there's 1, and then these. Okay, so we're getting some traffic on 4, and then we're seeing some traffic here.
So we're missing still a BGP neighbor, which
Well,
isn't up yet.
that neighbor no longer exists. So I should have 1, 2, 3, and then 4. And then if I connect over, I want to go to 3.
So from up here from the display, for the ones who are close up, you can see basically the traffic works normal except the host 1 currently receives traffic from everyone else, but he cannot send to host to 3 and 4. So 1 cannot send to 3 and 4, but it receives traffic from them.
Should. That's 1. I still not seeing it? I'm assuming. He's receiving. This one is not. Okay, I've possibly done wrong. Everything. So we're connected up. We see it. Let's look at this. So we're seeing one. Okay, so for those of you who don't know the deluxe interface, essentially what we have here is we have the first OpenFlow switch, which is 273, and connected to it we have the different links. And then over here we have switch 274, and connected to it we have the different links. So why is that still not working? So, this is something we spent many hours yesterday debugging, but essentially, when the interface goes down on the Raspberry Pi, sometimes it doesn't come back up correctly, and we don't get a default route in.
So yeah, so that was a bug on here. So things we hacked together and hacked a bit too much sometimes.
Okay, so what we have now is this setup. And in this setup, basically, Quagga is operating. It's acting as a gateway. It's running BGP both with device 3 and with device 2. Device 4 no longer exists. And then we've got the different hosts connected up, and they're all talking to each other. And so essentially it's similar to if we had a route processor and say two line cards here. That all makes sense? Go ahead. So in this case, it will actually go through the PC here. And one of the things that we were hoping that we would be able to demonstrate today was actually putting in forwarding information. And there's a couple of different ways that we could have done that. One of them, and I'll show you this, is that we have an interface in Quagga that allows us to basically pull out the entire routing table and then format it in a way. Now, here I've just kind of hacked together a tool that connects up to Quagga, grabs all of the forwarding information, and then would attempt to put it in. You can see I've got some formatting errors in here. But essentially what we would do is something similar to this. We can also do it by using an API call. basically just going in and doing an API call, which is how many people are doing it today. We can do it by programming some sort of an intent. There's a bunch of different ways to do this so that we can get the traffic to go from, and I'm assuming your question is how do we get host 1 and host 4 to go directly through the fast path? Yeah. And so my hope was that we would be able to demonstrate some sort of a way to do that. But right now what we have is a basic L2, L3 network that has been migrated over to under the control of the OpenDaylight controller. And then from there, we can go ahead and do other features.
So it's a little bit different for some of the application when you have seen it where they only use BGP and use basically a BGP client which is built into the controller side. But what we're showing here is like more like in an enterprise network where you have an IGP which is something else, so OSPF. So they are like a little bit different, and the ways to get it out, the FPM in the case of Quagga would be one choice. There are obviously different ways to get that on too.
So here I've just got a copy of what the configuration looks like, right? We've given these over to OBS. We've got the switch enabled. And then here we have the interfaces that we've added to there. And then I can technically remove this guy from there, from BGP, and then that would be the functional. So one of the things that I was thinking about, although this could go terribly wrong, is we can show some sort of redundancy here, hopefully. So what I've done is I pulled the link between 2 and 3, and then my hope is that the traffic will reroute and come back up.
And keep in mind, if you think it's a
go.
slow failover, well, we haven't optimized anything. This requires OSPF and BGP, and we didn't worry about changing any timers there. So if you want, you can obviously in OSPF, we can do a lot of setting timers to make it fast convergence, and BGP as well. But for the demo, we figured it's nice if it's a little bit slower anyway.
That's not a good one. In that case, that should have worked. Oh, never mind. So right as I plugged it in, you'll notice that it actually finally converged while I was starting to get very concerned. So general questions, concepts, ideas. People want to know more about the little boxes. I get a lot of questions about the boxes, and Martin can go ahead and explain more about them.
Well, the boxes, if you're interested to build something, I can give you all the details, but it's basically nothing special. It's a Raspberry Pi in there with some display on it, some graphical. It's just something I built because for some of the demonstration, I always need some host. I don't want to just on a router, and bringing so many pieces along is a bit painful. So,
Also, if we were to use,
feel free to contact us and we can get you the exact details if you feel like building that, improving that, cloning that, or whatever thing.
Yeah, we really like them. They're actually really good for doing demos where the students need to actually do work. and they're checking connectivity between each
So,
other.
so the special thing I did there, which we haven't used for that demo, is you can actually change the IP on there. And what we have, because I was thinking it's painful if I have to tell everyone else what IP to ping for, they have a separate wireless link in there, not IP-based, basically. It's some of these low-powered RF links, which they broadcast their own IP, so other ones can pick that up, and so they learn about each other's IP that way.
So I'll go ahead and reboot one. And what they'll do is, as he mentioned, as they come up, they'll send out messages over a low-powered wireless that allow them to detect each other. So if I was to go in and say change the IP on this one to, I don't know, /23 or something, I would be able to pick
So
up.
that is covered quite fast right now. It's also because I realized I suck on doing collision detection on wireless links. So I had this issue at the beginning. They always like collided each other, transmitted over each other. So I also did, like, whenever they receive a packet from someone else, because the other side already guesses the IP, then they learn it from that way too, so to speed it up. But one of the key things was also to be able to detect one-way like links, which a normal ping cannot really tell you if you receive it. That's what I have in there. So it's basically, I see ping times, which you can see in here too, by the way. That should probably, it's actually interesting there, but at the same time, so we have about 1.7 milliseconds. So the time is basically the ping time, but the bars is basically on a UDP protocol, so I can detect the one-way part too, where they have a fingerprint in it, so the receiving side and who is sending everything, and have checksums and part in there.
So the other thing to note is really we're using the equipment that we have. So one of these Pika 8s, I actually found at Weird Stuff for $20. And so I was really happy about that. But we're using what we have, and we kind of rely on the community to get us equipment in order to do things. You've seen some people have seen some of the other testing that we do. Can you explain a little bit about open source routing?
So yeah, I can also talk about, it's also one of them things is like a TP-Link in there, which I has mentioned, which basically runs OpenWT with like Quagga on it, just as a router. We figured why not have something else. And so as he mentioned, open source routing, which is one of the large activity on NetDef. We basically work on Quagga. We basically do testing on the mainline Quagga, pay maintainers and stuff there, and work around there. And the OpenWT specific, that's something I'm not sure if anyone here was at IETF last week in Prague. So we basically showed that the bits and bytes there, where we did some with HomeNet, like source destination routing with ISIS on Quagga. So, okay, somebody missed the good stuff.
I think the username is config on that one. 0.2. Is that right? Oh, it's root. Okay. So this is the OpenWRT, and this is actually a question that I put up on Twitter too, to ask, originally I had 2 Cisco boxes, 2 Pika 8 boxes. The reason that we keep the Cisco in there is that we want to make sure that everyone understands this is all interoperable. So it doesn't matter what routing protocols we're running, how we're doing the traffic, what we're doing. We want everyone to understand that this is.
So take the Cisco as a placeholder for a generic, like classic standard router. And the OpenWT just to show anything else which can basically do routing.
That went a lot faster than I thought it would. Do we have more questions?
Yeah, so if there anything specific question, there are some.
So you want the original topology? Ah. So these 4 devices are the 4 devices that are here, and L3 device 1 and L3 device 4 are now operating essentially as the same switch.
Yes, these are the two switches.
Correct. The 274 and the 273 are the ones that we see here. Okay. So 273 is switch device number 1, 274 is switch device number 2, and then again, for those of you who know OpenDaylight Deluxe, it's pretty simplistic, but you can see here, here's the host 10110, and then over here, we're going to have the host 104410, which is here, and then we have a link between them, which is port 2, that's being utilized by OpenDaylight. Okay. So does everyone understand what the other hosts are? Essentially, this is Quagga, where we have the interface 172.16.3.1 and the 10.4.4.1. And then over here, this is a link over to device number 3. And this is a link to the host. This is a link over to device number 2. And then this is Quagga on the first switch. See, most people are looking down.
Anything other question specific?
So my only other option is I can convert everything back, if you want. I can reboot things and do all sorts of craziness. It really depends if anybody wants to see anything, but otherwise we're. Oh, go ahead. Yeah. Well, you raised your hand.
So, in terms of doing the migration, right? So you worked it out. Is there any sort of feature set that you would like? Yeah. So in terms of doing the migration, right? You worked it all out. You have your series of steps on how to do it. Is there something drastically missing that would have made this a lot easier for you? What sort of functionality is missing that would have made this a less manual process, perhaps?
A less manual process.
I'm not saying it was horribly manual, mate, but I'm just saying, is there
Yeah.
something, if you wanted to migrate from a traditional to OpenFlow, what's missing that would have made it a lot simpler, do you think? Or
So
ease that
one of the
migration?
reasons that we're demonstrating this, and it's so simplistic, is that we got some feedback from guys over at very large search companies and places like that who said, we've got these OpenFlow controllers, we've got these SDN controllers, but they're not looking at the very simple, straightforward part, which is, how do you actually get them working in the network? How do you get this going so that you can then do the extra features, the sexy things that people want to do? So yes, I want to do group-based policy on top of this, and truthfully, if I had all of the time and all of the features available to me, we would have put this in. So there's another thing that's going on, I don't know if everyone's aware, which is a project called Atrium that ONF is dealing with. And Atrium currently uses ONOS, and then it runs IBGP with Quagga, and then distributes the routes into ONOS via IBGP. We're looking at how we can do that with OpenDaylight, and whether or not we're going to port the same code over into OpenDaylight. I also looked at using RouteFlow, which if anyone knows of that project, that's an early project, but it was supported in OpenDaylight Hydrogen, and then basically when it changed over to Helium, it no longer functioned, and there was a lot of work to rewrite that. So
let me add something from the routing side. I mean, as I say, like what he mentioned, the Ethereum with like doing the IBGP, what that seems to work because mainly BGP is quite easy for people to hack together protocol, and they use that for programming flows into it. However, a lot of the enterprise networks, they are not pure BGP. They don't use BGP internally, so they have an OSPF or potentially even ISIS or something else internally, and where you need both things. And that's where it's currently basically a bit lacking. So how you basically get some of these routing things programmed into as flows. And we showed here, Steve showed a little bit the FPM interface, which in Quagga is in there. I think outside of some experimental, I haven't seen really anyone trying to use that. I haven't really seen much other solutions there. Something where you take from a routing daemon basically all the routes combined, and don't worry, it's basically what routing protocol, and allow all routing protocols to convert that over into flows and program them into a switch.
So taking the fib
Basically, yes. Think like a distributed router, really the classic example where each OpenFlow switch is basically a line card and you have a control plane, and you basically want the combined fib of all the routing protocols basically push that down. I say that was what the FPM originally was written for, and just not really used much so far.
go ahead. Right. Sorry.
So in general, I would say, for me, what independent of exactly what we're doing here, the optimal case would probably be just programming the layer 3 flows, most likely, which is quite a bit less. And I would say optimally, you can even somehow compress the layer 3 tables to make it less, because most of the OpenFlow switches don't have such a large TCAM space or whatever space they use for programming in. However, in this example here, I think we do mostly layer 2 flows, if I remember correctly, what we're programming in. Steve can probably correct there.
Yeah, it's all layer 2 here. I thought about possibly just shoving some flows in via the REST API or something like that.
Can you show the programmed flows?
Oh.
Let's see if we can show the flows, how they're programmed in there right now.
Well, they're not anymore, because I've rebooted everything back into L3 mode. But here you can see the flows, that we're getting the different, it's going out 3, going out 2.
It's obviously also depending on your network different. I mean, maybe if you don't have that many hosts, maybe layer 2 flows might be even taking less space, and there may be less flows, so that might be even preferred over having layer 3 flows programmed in there too.
Would it be a helpful approach if you took and used RPSL as an intermediary format? So you would take all of the routes that are advertised by different protocols, ISIS, OSPF, whatever it is, aggregate them using RPSL as a language to do that, and then advertise them all from the BGP speaker that's built into OpenDaylight. So you weren't subject to those limitations of the individual devices, and you had a single source of truth for all of the L3 routing decisions in the network.
So when you speak of the BGP speaker in OpenDaylight, one of our problems essentially was that while there is BGP PSEP, it itself doesn't install the routes into the forwarding table.
What if you had that though?
Well,
I'm validating an approach.
if I had that, the demo
So-
would have been quite a bit.
If I understand you correctly, you basically would redistribute all the routes back into BGP and basically from the routing side and advertise it over. In general, as a routing person, I don't feel comfortable on that part, but we can discuss a bit more in detail. I believe it's probably not the best approach. I always say, like, why wouldn't you have like a nice interface in the FIP part of the routing daemons and basically pick it up the routes, all that, and leave the decision which protocols in what and distribution, all that stuff out of like the whole OpenDaylight part. I think that would be the better approach, just basically have an interface into the FIP directly.
So that's actually something that we're constantly thinking about is we've got a way to dump a fib, and we can do that from other devices too. The reason the FPM was created was to be generic across other systems if possible. But once you have that fib, you then have to somehow get it into the system to forward. And really, OpenDaylight shouldn't care about what the routing protocol is or how it got that route or basically anything. It should just care that it has this from here to there, kind of an entry that goes into it.
I also want to add, if you have some, if you start to think about how to do that from the open source routing project, the Quagga side, we are very interested to have that. On the Quagga side, this FPM was done long time back. It's probably seriously broken for what you need, but it really lacks some input from this side on it, trying to make that in universal something or completely abandon and start it over again if that's the right approach. So, but if you are thinking about that, if you think you have a solution, feel free to approach us. We will be very interested to see that and make sure we can get somehow like at least the Quagga routing daemon basically done in that way, so you can actually have the best possible interface.
So I don't have a heck of a lot more to talk about. Really didn't expect to move that fast. Here you can see everything's back up. We're now in a generic L3 format. All I did was just copy the configs over, reboot. Everything's back up and running.
I would say we can be done. Otherwise, feel free to come up, look at it. You probably can't really see it from the back. If you want to come up here and look at it, or even like see what happens if you pull some random link, or did you move everything back?
Now it's all L3, so,
Okay.
so hopefully it should recover.
But we can show a bit up close, a bit more in detail. So if you want to have a look a little bit how the whole things work. You okay?
Okay.